Okay, graphing tangent and cotangent. It was the first part here of Objective 7. And so we have kind of a picture here with the translated form of both tangent and cotangent, but I did want to start by showing what tangent actually looks like and then what cotangent actually looks like so we can see what's happening with our translated form. So this is what the tangent graph looks like between negative 2 pi and 2 pi. So the actual tangent graph here crosses at 0, 0. Let me see if I can get this to focus a little bit more. There we go. So the actual tangent graph here crosses at 0, 0. What that's going to mean for our translated tangent graph is that because tangent crosses at 0, 0, our HK, our starting point here, is going to be the crossing point of tangent. It's going to be that middle value of tangent because that's where 0, 0 occurs on my tangent graph. Okay? And then tangent has asymptotes at negative pi over 2 and pi over 2. Okay? So that's what makes the guts of your tangent equal negative pi over 2 and pi over 2. So obviously, again, with a regular tangent graph, let me grab a little paper here. With a regular tangent function, y equals tangent x, my asymptotes then exist when x, what's in here, equals negative pi over 2 and pi over 2. Okay? What that's going to mean for our translated form is, notice that we don't just have x inside of tangent. What we have is b times x minus h. And so since that's what's inside the tangent, that's what's going to equal negative pi over 2 to pi over 2, and pi over 2. And so then if we wanted to find our vertical asymptotes, we would divide our b over. We get negative pi over 2b. And pi over 2b. And then we would add our h over, and we get h equals h plus the negative pi over 2b and h plus the positive pi over 2b. Okay, and so if you notice, that's what our two asymptotes are marked as, h plus negative pi over 2b and h plus pi over 2b. So the asymptotes exist at those locations because of our parent graph of tangent x. Okay, and then the period for tangent, let me get this to focus here, sorry. This tangent graph occurs once every pi intervals. So if you notice again in negative 2 pi to 2 pi, where cosine and sine, we would see them occur twice, because again, cosine and sine take 2 pi. So negative 2 pi to 2 pi would occur once, twice, that repetitive motion of cosine and sine. Tangent, we see it happen 4 times because tangent's period occurs twice as frequently. And so instead of 2 pi over b, our period is going to be pi over b. Okay? Your amplitude then is going to be reflected here between your middle and your quarter or 3/4 point and your middle and your quarter point. To get tangent to flip would mean to have your coefficient be negative. Okay? And then domain and range. So domain is going to look a lot like secant and cosecant's domain. We will always express it as some value that x cannot equal. And range will be all real values because tangent goes up and down indefinitely. So you can either write all real numbers or negative infinity to infinity, whichever one you prefer. Okay? Cotangent graph then. Let me go ahead and put a cotangent graph on the screen. So compare that. Here's a cotangent function. Okay, so the cotangent function looks very similar to tangent because it is the reciprocal of tangent. HK though is located in a slightly different spot. Notice that your 0, 0 on the cotangent graph exists on the asymptote. So our HK is going to exist over here on the asymptote of our function. Okay? Your two asymptotes for cotangent exist at 0 and pi, and so similar to tangent, since cotangent x has asymptotes at 0 and pi, x would be 0, x would be pi, the guts of that cotangent there. Since my guts over here are b times x minus h, that's what's going to equal the 0 and pi. And so then dividing the b over, we get 0 and pi over b. And adding the h, we get h plus your 0 over b. Should put the b there too, I guess. It's divided by 0, so it doesn't really matter. And then h plus pi over b. Okay, for h plus 0 over b, h plus pi over b for your two asymptotes. Okay, and then again, your period, like tangent, is going to be pi over b, and then domain and range will similarly reflect tangent. Okay? And then also, like tangent, this will be your amplitude. Okay? Okay, so graphing these, we've got two of each. My recommendation is maybe to watch one of them and then pause the video, give the second one a shot. Or if you feel like based off that explanation, you want to try to kind of do the first one on your own and then listen to how it's done and correct your work, and then still pause the video and try number 2 on your own. You could do that, but we're going to do 2 of each. Okay, so first one, tangent. We have y equals 2 tangent of 2x. Okay, so getting it in descriptive form, we have nothing to add or subtract over and nothing to factor out, so we're good to go. My HK then is going to be 0, 0, and that's going to be my starting point. Okay. And then my asymptotes for tangent, so asymptotes for tangent exist when your guts, which in this case is 2x, equals negative pi over 2, equals negative pi over 2 and pi over 2. And so then if I were to, goodness sakes, I'm sorry, let me rewrite that. I started to talk about pi over 2 and negative pi over 2 before I had actually finished writing my problem. So let me start again. Asymptotes, when your guts, which in this case is 2x, equals your asymptotes, tangents, asymptotes are at negative pi over 2 and pi over 2. There we go. That's better. And so then my asymptotes, when I divide this 2 over, will occur when x equals dividing 2 here, negative pi over 4, and dividing 2 here, pi over 4. Okay? And so we've got one asymptote back here at negative pi over 4, and one asymptote here at pi over 4. Okay. Your amplitude in this particular case, my amplitude is 2. And so I'm going to be going up 2 and down 2 for my 1/4 and 3/4 points. And we've got our tangent graph. Okay, so something like that. And then again, like with all of your trigonometric functions, you could keep this pattern repeating if you wanted to, for as many times as you would like. So coming up, curving over, and up again. You'd have a second iteration of it. Okay, period actually doesn't end up impacting how we graph very much, but I still recommend identifying what your period is, which is pi over your b. My b in this case is 2, so pi over 2. Only just to make sure that your period is reflected on your graph, so that's how many times, or that's how long it takes for my pattern to end or start and end. So from negative pi over 4 to pi over 4, is that a distance of pi over 2? It is. And so it's just kind of a way of double checking. Okay. Domain in this case, your asymptotes are at all of your odd pi over 4s, and so you would reflect your domain that way, all odd pi over 4s, and then range would be negative infinity to infinity. Okay? Okay. Number 2, pause the video, give this one a shot on your own. Okay, so getting this in translated form, we do need to subtract that 2 over. Y minus 2 equals tangent of x minus pi over 4. Nothing to factor out there, so we're good to go. Okay, pulling out my HK. My H in this case is pi over 4. My K is 2. And so that's my starting point at pi over 4, 2. Okay, asymptotes next. So my guts in this one are x minus pi over 4. And so they are going to be what equals negative pi over 2 and pi over 2. Adding that pi over 4 over, we get pi over 4. I'm sorry, negative pi over 4. And pi over 4 added to pi over 2 is 3 pi over 4. So I've got one asymptote back here at negative pi over 4 and one asymptote over here at 3 pi over 4. My amplitude in this particular case is 1. And so I'm going up 1 and down 1 on either side. So we've got our tangent graph here. And again, you could repeat that one a couple more times if you wanted. And then we've got our graph. To double check, period in this particular case, pi over b, my b is 1. And so my period is just pi. Is that the distance from negative pi over 4 to 3 pi over 4? It is, and so I'm pretty sure I did it right. Domain in this particular case, my domain's at negative pi over 4 and 3 pi over 4, so you would articulate your domain in terms of that pattern, and range would be negative infinity to infinity, as is going to be the range for all your tangents and cotangents. Okay? Okay, numbers 3 and 4 then. So number 3, again, if you would like to pause the video and do this one on your own, you can. Just make sure you're thinking about the cotangent graph that we talked about earlier. Or maybe watch number 3 and then pause the video and try number 4 on your own. Okay, so cotangent, getting this into its descriptive form. It's already in its descriptive form, so pulling out my HK in this case is at 0, is 0. Now with cotangent, remember your HK is no longer your center point. That's tangent. Cotangent, my HK is actually on my asymptote. Right? Sorry about that. So in this case, if I put my 0, 0 on my asymptote, it drops here. Okay. My other asymptote then, you know that 1 is going to be at x equals 0 there. So the guts of my cotangent in this case are 1/2 x. They are set equal to cotangent's asymptotes, which are 0 and pi. And so when I multiply that 2 over to the other side, I get 0, which confirms what I originally found, and 2 pi. And so 2 pi is going to be my other asymptote over here. Okay. Middle point will be in line with my HK here. Right? So your middle point here is in line with your HK. Okay. And then quarter point and 3/4 point, my amplitude in this case is 1. Now it is a negative, but that just tells me my cotangent graph has been reversed. And so we are going quarter point, 3/4 point, up 1 and down 1. And we've got our reversed cotangent graph, which looks a lot like the tangent graph. Okay. Oh, and then you could also find period, domain, and range. Period would be pi over b, which b in this case is 1/2, so my period would be 2 pi, which is the distance from 0 to 2 pi. So. Okay. And then last one, go ahead and pause the video, try this one on your own, restart it when you're ready. Okay, getting this one into its descriptive form, we just need to factor that 2 out. 2x minus pi over 2. My HK then is pi over 2, 0. So that's going to be my asymptote. Again, remember working with a cotangent graph. So I know one of my asymptotes is going to be at pi over 2. The question is, where's my other? So my guts in this case are the 2 times x minus pi over 2. And that's getting set equal to 0 and pi, cotangent's 2 asymptotes. Dividing the 2 over, we get x minus pi over 2 equals 0 and pi over 2. And adding pi over 2 over, we get x equals pi over 2, which confirms my initial asymptote here. And adding pi over 2 to pi over 2, we get pi, which will be my second asymptote. Okay, middle point in line with your HK. Amplitude in this particular one is 3, and so we're going up 3, down 3 for 1/4 and 3/4 points. Okay. And then double checking period, domain range if you would like to as well. So period in this particular case would be pi over my b. My b is 2, so a period of pi over 2. Well, pi over 2 to pi is a distance of pi over 2, so I'm pretty sure I did it right. Domain for this particular one would be all of our pi over 2's. Over here we have all of our even pi's. Okay, and then range for both would be -infinity to infinity. Okay, and that's graphing tangent and cotangent graphs.